Now we're going to talk about some selection decisions, the things that we do as the organization does to actually decide who to bring in. So, as we talked about in the module on predictors, most of the time you're not going to use just one. You're not going to say, I'm just going to use an interview, and based on nothing but the interview, I'm going to make the selection decision. No, there's going to be a battery. We talked about batteries earlier. A selection battery would be a set of tests, okay, that work together, all right? So, absolutely, as we saw before, here's an example of using a selection battery. And the selection battery will involve an interview, the assessment center results, a work sample. And we can see that the R squared is, for the interview alone, is 10%. And that's to say, again, the way we interpret that is to say, if I were to interview candidates, it would allow me to understand 10% of their performance on the job, something like that, 10% R squared. If I were to use the assessment center alone, I could predict 25% of the performance on the job. If I used a work sample alone, I could predict 36% of success on the job. But what you can see is because some of the things that are being predicted overlap, therefore, if you put these three together into a selection battery, you get multiple R squared, the R squared, big R squared, of 0.55. Okay, so it's 55% if we put it together. And so now, by definition, if I add another selection, another test predictor or test to this battery, then that bottom 0.55 will go up, right? By definition, it goes up. But you can see that if I add more and more and more, there's going to be more and more and more overlap. And so as I continue to add more, the prediction that they add becomes smaller and smaller and smaller. Okay, so clearly, in a good selection battery, you want to maximize R squared, you want to minimize overlap, and obviously you want to minimize time and cost. Okay, so we'll talk about those in the next video. So here we go. The selection of an employee should be based on valid tests that have been demonstrated that they reflect reality, that they predict what they should be predicting. Okay, and so there's variety of ways to demonstrate how valid a selection battery is. Now, it's fairly easy to validate a single predictor. It's just the correlation. You get the score on the predictor, right, on the day you hire them. Then maybe a year later, you look at their performance on the job, and then you correlate the two. Okay. Now, it becomes a little bit more complex when you start to look at a battery rather than a single predictor, but it's the same concept. Okay. So, yeah, we want it to be, yeah, I already said that. Okay, so if we use a battery of tests, how do we combine the information from multiple tests? And so we're going to, or multiple predictors. I keep using the word test. I guess tests and predictors are kind of synonymous words here, right? And so there's two main ways, the multiple cutoff approach or multiple aggression. Multiple aggression. See, that's funny. No, multiple regression, okay? Apparently I paused it. I don't understand what I did. Okay. All right. So multiple cutoffs or multiple regression. Okay. So the multiple cutoff approach, what's going to happen is you're going to have a selection battery, and you're going to have it such that at every one of the tests in the battery, you have a minimum score that you must pass, okay? And so here is a simple example. So let's say they're doing a cardiac surgeon. They want to hire a cardiac surgeon. And so they're going to have a test battery that includes the medical school GPA, which is cheap, right? Cheap to measure because it's just sitting there. Then a medical knowledge test, which is probably just a paper and pencil test, which is relatively cheap. Then a psychomotor test, and I'm assuming that would be like dexterity kinds of things. And then finally, an interview score. Okay, so they take an interview and how do they do? And so then what's going to happen is they have 6 applicants for the position. And you see in the bottom row, they have a cutoff for these predictors. And that is to say, if the medical school GPA is below 7, do not hire, period. I don't care what everything else looks like. If it is less than 9, do not hire. I don't care what they look like. And so you can see what's going to happen is we're going to have some composite scores here, total scores. Based on the total scores, we should be hiring Dr. Welby. He's got a 37, he or she, but this is Marcus Welby. It was a television show in the 60s, so it was a he, so Marcus Welby. And but what's going to happen here is though Welby has the highest overall score, Welby failed to meet the minimum cutoff on the medical knowledge test. Therefore, there is only 2 applicants, Dr. Brown and Dr. Seuss, that have passed every one of the cutoffs, but at this point, Dr. Seuss has a higher overall score, higher Dr. Seuss. Okay? So in a version of this multiple cutoff approach, because the multiple cutoff approach is time consuming, expensive, let's take the same idea and just go like this, okay? We're going to put them in order. That is to say, put first the cheapest, fastest one, the second cheapest, fastest, the third cheapest, etc. And so we're going to start to administer these portions of the battery. Dr. Oz is out. Why am I going to waste my time and money measuring Dr. Oz on anything else when the cutoff has already been cut? And so you move to the second one. And as you proceed, the pool of applicants gets smaller and smaller, and you get the same comparison at the end, but you saved a lot of money and saved a lot of time. Okay? Multiple regression is a different approach. It's the same idea. You're going to combine the results from multiple batteries, but what you find here on this approach and the previous one is that each and every one of these 4 predictors, is it 4? Yeah, 4 predictors is equally weighted, okay? Like somehow medical school GPA is just as important as interview score. I don't know if that's true. I mean, maybe. I don't know this thing, okay? So multiple regression will combine these different predictors, but will do so based on linear regression scores. It's simply a simple calculation. It looks confusing. I see that, but I'm sure some of you remember y hat equals bx plus a. Okay, and so here is a version of y hat equals bx plus a, but it's now multiple. In this case, there's 3 predictors in this equation, and so it's simply saying the predicted value of y. In this case, the predicted value of y is job performance, right? How good somebody will be on the job, equals B1, some weighting factor, times the score on the first predictor, plus a weighting factor, B2, times the score on the second predictor, etc., plus a constant, okay? And so using this type of a setup, you could, for example, here is a on the bottom here, bottom right, you can see the predicted value of y equals 1.54 times x1 plus 0.75 times x2 plus 0.32 times x3. And so what they're kind of indicating here is based on these weightings, okay, the first predictor of work sample is given a lot more weight here. They're not just going to add these 3 together. And so the company has decided that work samples are much more important than an interview score. Maybe it was based on the, in fact, you know what? It's probably based on, I'll bet you I remember. Patience right here. I bet you it's based on this. Look at work sample clearly is more important than assessment center, and assessment center is clearly more important than interview. Therefore, when I weight them here, I'm going to weight them in the same type of a way, okay? Work sample should be given much more weight to it. And so using this, you'll get a factor score or something that's whatever. But you're going to get yourself a score. And now all of a sudden between these, you're going to be like, I guess we're going to hire Harlan. All right. Harlan is going to be predicted. Am I going to be right? We're going to talk about that in the next little video, okay? But based on this selection decision procedure, Harlan gets the job, okay? So next time we're going to talk about how expensive they are, how to choose them, and things of this nature.